welcome to Easy Electronics. This is a part 3 of NESAC Technical Assistance Solutions. Okay, so let us see what is the first question. What is the job of a compiler in a microcontroller programming? Okay, so there are various tools we use while coding or while programming in order to actually convert one form of code to another form, or in order to make the code actually understandable for the machine. So we are actually programming for working in a hardware, right? So the hardware or the machine understandable form is only ones and zeros, and this is called machine language. Okay, so while we are writing a high level programming, whether it is a C programming or C++ programming, or in any of the high level programming, that has to be converted to the machine language. Okay, so this conversion from a high level, that is human understandable form. So when we write add a comma b or add a comma c, it is a human understandable code. Okay, so that is not machine understandable code. So we have to convert the high level language from the human understandable form to the machine language, which is ones and zeros. So that is actually achieved with the help of a compiler. Okay, so here the options given are: translates high level language to assembly language, B, translates high level language to machine language, C, translates machine language to assembly language, D, none of this. So the correct answer here is option B, that is translating of high level language to a machine language. Okay, so there are various other tools also we use while coding. Let us discuss some of those. Now we have talked about compiler, which is converting a high level language to a machine language. And next is an assembler. What is an assembler? Assembler converts a assembly language to a machine language. Okay, so we'll be writing, for example, it is a move a comma b, or move dptr comma hash 4500. So these are all assembly languages, and these assembly languages need to be also converted to machine language. So this is achieved with the help of an assembler. Okay, so an assembler is a tool, or it is a software tool which is used for converting an assembly language to a machine language. Next, what is a debugger? Debugger is actually used for debugging any errors present in the codes. So while we are coding, there can be a lot of errors happening. For example, there can be a syntax error, there can be some opcode or some coding errors that can be, or there are a lot of errors that can happen. So we have to make the code first error free, then only we can run the code, right? So in order to make the code error free, we use a debugger. Okay, so debugger is a tool which is used for debugging of code. Also, another thing is that we use a page, or we use a software, or we use a separate tool for writing the code, right? Now, what is this tool called? It is called editor or text editor. Okay, so you may be familiar with all these words. Anyway, I'm just telling you. Editor, or specifically text editor. So editor window, we say editor window, or we say editor tool. So this editor is used for editing of code. So in this editor, we are actually writing the code. So we open a blank page and we are writing the code, means we are actually opening the editor, text editor or editor. Okay, so these are some of the tools which you can probably see while using an IDE, which is an integrated development environment. So while combining all these things, that is text editor, debugger, then compiler, assembler, or everything is combined together. Not everything is needed for all programming, but anyway, if you are combining compiler or text editor or debugger, all these tools if combined together, it forms a bundle which is called a IDE, or integrated development environment. Now, what is an IDE? IDE is actually a mixture of all these tools, and it is actually an environment where you can perform programming. That is, you can perform editing, you can debug, you can run, you can compile, and you can run. All these things you can do in that environment. Means it is a mixture of all these tools. Okay, So that is IDE or Integrated Development Environment. Okay, now why I am saying all these things is because in this question they have asked about compiler. In some other question papers or in your upcoming question papers, they may ask about IDE, or they may ask about assembler, or they may ask about editor or debugger or any other tools. So you should be able to answer this question, because if this question can come, another type of questions can also come, right? So that's why I have explained all these things. I hope this is clear. Anyway, the correct answer for this question is option B, which is translating of high level language to machine language. Okay, so now let us see the next question. Okay. Next question is, in a free space propagation, as distance d from the transmitter increases, the received power reduces by dash. A, factor of d, b, factor of d cube, c, factor of d raised to 0.5, that is root d, d, that is next option, factor of d square. Okay, now in order to answer this question, you only need to know this equation. In the case of a free space propagation, the path laws or the equation for the received power by transmitted power, PR by PT is equal to, or you can write PR is equal to PT into, you can also write that. So anyway, PR by PT is equal to dt into dr into lambda by 4 pi d the whole square. Okay, so PR is the received power, PT is the transmitted power, dt and dr are the directivity of antennas. For dt it is directivity of transmitter antenna, dr is the directivity of a receiver antenna, lambda is the wavelength, then d is the distance between the transmitter and the receiver. Okay. Now, in this question, they are asking when the d, that is the distance, if it is increasing, how will the power affected? That is how much the power reduction is happening. So, from the equation, it is clear that PR is proportional to 1 by d square. PR is proportional to 1 by d square. So, what will happen if the d is increasing? PR is reducing by 1 by d square times. Okay. So, that is when the, not by 1 by d square times, when PR is increasing, is proportional to 1 by d square means it is reducing d square times. That is inverse proportionality it is. So when d is increasing, PR is reducing by d square times. Okay, so the correct answer here is by a factor of d square, because it is having a square relationship. Okay, so anyway, if the distance between the transmitter and the receiver antennas or the transmitter and receiver is increased, the power has to be reduced. So it reduces by d square. The next question is this. The BCD number of 1001, 1010, 1011 has dash. A, no parity. B, parity cannot be determined. C, odd parity. D, even parity. Now what is actually parity? Parity means the number of ones present in a particular number. Okay, for example, if this number 1011 is given to you, this number is having 1, 2, 3 ones, right? There are 3 ones present in this number. So this number is having 3 ones, and since it is an odd number, 3 is an odd number, right? So we say that it is having a odd parity. Okay. Also, if this number is having only, say the number is 1010, then it is having 2 ones. So it is called, or it is having even parity. Very simple, right? So if the number of ones present in a number is odd, then we say it as odd parity. And if the number of ones present in a given number is even, we say it as a even parity. And this parity is actually used for determining whether the number is even or odd. Okay, so generally parity means the number of ones, and if it is even, it is even parity. If it is odd, then it is odd parity. Now in the given number, the number is having how many ones? Let us count the number of ones. Okay, so 1, 2, 3, 4, 5, 6, 7 number of ones are present. So there are 7 ones in this BCD number. So this 7 ones, 7 is a odd number. So this is what parity it is? Odd parity it is. Okay. So the correct answer here is option C is the correct answer, which is odd parity. Next question. Which of the following memories is slowest? So now we are going to talk about the computer memories. And while talking about computer memories, the memory can be basically divided into 2 types. Okay, there is a physical memory. I'm sure you have heard about these words. And there is virtual memory. Okay, you may have heard about paging and all. So this paging also is a concept related to this 2 type of memories. Now, what is a physical memory? Then what is a virtual memory? Physical memory means the memory which is actually or physically present inside the system. The physical memory example is RAM. We know that there is a RAM present inside all computers, right? So this RAM is physically present inside the system. That is, that memory is present inside the system. So that is why we call it as a physical memory. Now, what is the difference between this physical memory and virtual memory? Virtual memory, most of the time, is a secondary memory. That is, that memory is actually not present inside the system. For example, a hard disk. See, we know that hard disk we use as for a secondary storage. That is, this hard disk we use for storing the data which is not actually fitting into the RAM, or for storing the data which we are not using frequently or not required every time. So these type of data we store to hard disk, and whenever we are in requirement of that data, we will retrieve it from the hard disk. So that is the process we are doing. So if you talk about the hard disk, that hard disk memory is not actually present every time in the system. So there is a memory there, but it is not physically present inside the system every time. We are only accessing the memory whenever we are in the requirement. Okay, so such type of accessing is called virtual accessing, and such type of a memory which is when we need it, there is that memory that is present there, but when we are not in need of that data from that memory, it is not considered as part of our total memory, right? So there is a virtual memory, there is some memory present there, we can access it whenever we want, but it is not actually present every time in the system, and hence we call this memory as a virtual memory. So this hard disk is called as a virtual memory. Now we are talking about the speed of these memories. Okay, so while talking about the whole system, the most speedy memory, or the memory which is having maximum speed is cache, because we know that cache is a fast accessing memory. When we need some data very frequently, we store that data into cache. Okay, so or cache. So this cache is actually very fast. And also, while considering the speed of RAM and hard disk, the hard disk is slower as compared to the RAM. RAM is actually more frequently used as compared to the hard disk. So RAM is having more speed and hard disk is having less speed as compared to that of RAM. So which is having more speed here? The physical memory or the RAM is having more speed as compared to the virtual memory. And also the virtual memories are expensive also. Okay, so the virtual memories are expensive and they are having low speed. Okay, so here the options, we have to find the slowest one. So RAM is not the option, cache is not the option. And also while comparing EEPROM and hard disk, EEPROM is faster as compared to that of hard disk. So the most slowest one is our virtual memory, which is the hard disk. Okay, so the correct answer for this question, that is, we need to find the from the options, which is the slowest memory. It is the virtual memory or the hard disk is the slowest memory. And the correct answer here is option B is the correct answer. The next question is this. In a 555 timer, the three 5K resistors provide trigger level of dash. A 2/3 VCC and threshold 1/3 VCC. B 1/2 VCC and threshold 2/3 VCC. C 1/3 VCC and threshold of 2/3 VCC. D 1/3 VCC and threshold of 1/2 VCC. So for you to get familiarized with the 555 timer, I am next going to include an image of 555 timer. Okay, so anyway, so let us answer the question first and then we will see about the image. Okay, so we need to find the trigger level. Okay, so this finding of trigger level voltage and also threshold voltage is nothing but voltage division. So why this is called a 555 timer is because they are using three 5K resistors they are using in the circuit. So that is why it is called a 555 timer. Okay, so here in order to find the value of trigger level voltage, if R is the resistance, then R by 3R into VCC is the equation. So here R and both R values are equal. It is equal to 5K. So it is 1/3 VCC is the trigger voltage. And for finding the threshold voltage, it is 2R by 3R into VCC. Okay, so the threshold voltage is equal to 2/3 VCC. So the correct answer here is 1/3 VCC is the trigger voltage or trigger level and threshold voltage is 2/3 VCC. Now, next is the image of this 555 timer. So by seeing that image, you will be able to find out why this triggering and threshold is based on the, that is they are based on the voltage division. We can find the trigger level voltage and the threshold voltage. Okay, so anyway, the correct answer here is option C. AM modulation is performed on a 5 MHz carrier. The message bandwidth is 2 kHz. Bandwidth of the modulated signal is dash. So, this is an AM system. AM means amplitude modulated system. Right. So, for an AM system, we know that the spectrum or the AM spectrum will be like this. There is an FC, there is FC minus FM, and there is two side lobes, right? Second, this is lower side lobe, this is upper side lobe. So, FC plus FM it is. Now, this is the AM signals spectrum or the representation. Okay, so here, how to find the bandwidth of this spectrum? It is by taking the difference of this upper side band minus lower side band, right? Anyway, in general also, in order to find the bandwidth of a signal, higher frequency minus lower frequency, it is a bandwidth equation. So here it is FC plus FM minus of FC minus FM, right? So this is FC plus FM minus FC plus FM. So this FC and FC will get cancelled. So what is the equation we are getting for the bandwidth? It is 2 times that of FM, right? So it is 2 times FM. FM is the maximum frequency of your message signal or your input signal or your modulating signal. Okay, so it is 2 FM is the bandwidth. Now in this question they have not given the bandwidth they have not given the frequency, maximum frequency of your input message signal, but they have instead given the bandwidth. So if you consider your message signal or your message signal, then let the lower frequency be minus FM and the higher frequency be FM. Okay, the higher frequency is FM, lower frequency is minus FM. So what is the bandwidth of the message signal? It is FM minus, that is FM plus FM. It is equal to 2 FM, right? So the bandwidth of your message signal is 2 FM. So here they have given the value or the bandwidth of 2 FM is given. It is 2 kilohertz. So what will be your bandwidth of the modulated signal? It will be again your 2 kilohertz itself. Okay. So the correct answer here is option A is the correct answer, which is 2 kilohertz. So the correct answer here is option A, which is 2 kilohertz is the correct answer. That is 2 kilohertz is the bandwidth of the modulated signal. If a resistance has to be measured by voltmeter ammeter method, the voltmeter can be connected across the source or the resistance. If resistance is low, voltmeter should be connected dash. So in voltmeter ammeter method, we use a voltmeter and we use an ammeter to measure the current and the voltage. So the general mode of connection for a voltmeter ammeter method is like this. We always connect the ammeter in series with the circuit. That is, if this is the source and this is the ammeter, and ammeter is connected in series because the current is getting, that is in series connection, the current is same and the voltage is same in the parallel connection, right? So the current, in order to find the total current of the circuit, we use the ammeter. So the ammeter is connected in series. And if we want to measure the particular voltage across any device, we connect the voltmeter across that device. That is a standard method of using a voltmeter ammeter method. Okay, so like this we will be connecting. So here we are using a resistance value which is low. Which is having low resistance value. The resistor is having low resistance value. So we have to connect the voltmeter across the resistor. Okay. So the correct answer is option A, which is across the resistor. Okay. So this is the voltmeter ammeter method. Voltmeter ammeter method means we are going to find the current of the circuit and also voltage. Sometimes the voltage across our device we need to find. So here we need to find the value of resistance. So for that we need to find the value of the voltage coming across the resistance, right? So for that we place the voltmeter in parallel or across the resistor. So that we can find out the voltage and then we have the total current in the circuit, so we can find out the resistance value, right? So this is how we can find the resistance value. Since the value of resistance is also less, we have to connect it across the resistor. Okay, so the correct answer here is option A is the correct answer, that is across the resistor. So these are the questions which I have included in this video. We will be seeing in the next part of the NESAC solutions. We are doing the videos as various parts. In each videos I'm trying to include 6 or 7 questions. And I'm trying to give maximum explanation so that you can answer the questions. If any other questions is coming from that related area, you should be able to answer, right? So it is just a waste if you just read the question and see the answer. It is a waste. You should have a concept about the question. What is this question actually asking? What is the related areas? All these things you should be able to figure out. Only then it is good or it is beneficial while doing a question answer video. Okay, so I hope you're getting that from these videos. And if you are finding these videos useful for your preparation, please do give it a thumbs up and also share this video maximum with your friends group and family group if anybody is preparing for these examinations or any competitive examinations of electronics. And also please do subscribe to the channel so that it is an encouragement to do maximum videos. And also please do tell your friends also to subscribe to the channel. We'll be doing a lot of preparation videos for the upcoming examinations, and also for subject wise also there are various topics I'm covering as per the request, and also some core subjects I'm doing as videos. Okay, so if you want more videos also, please do subscribe to the channel. Thanks for watching and keep on watching.